Good morning, 4G science students. Ms. Raymond here, and today we're going to be going over TEK 4.6c. I can demonstrate that electricity travels in a closed path. Now, science has a special word for that closed path, and that word is circuit. Here you see the word circuit, and notice the beginning of it looks very much like the word circle. Think about how there's no end to a circle, it's just connected everywhere. That's what you got to have a circuit. You have to have a complete circular path for electricity to travel through. If that circle is broken, the electricity will not travel through it, and your lights won't come on, your fan won't come on, your device won't charge. So you have to have a completed circle for the electricity to travel through. And we're going to demonstrate that today. I am going to show you some interesting things that I learned when my daughter was in school. So here I just have a regular piece of aluminum foil. It's hard to see because of the shiny lights and it reflects the light. Okay, but it's just a little piece of aluminum foil. And here I have some tape. And pull off a piece about as long as my piece of aluminum foil. And I'm actually just going to tape that right down on the aluminum foil, press it down. Okay. Now what I'm going to do, you see I have my piece of tape on the aluminum foil. And I'm just going to cut around this piece of tape. So on one side there's going to be tape, on the other side there's going to be aluminum foil. Now, I want you to think back to yesterday in science when you were learning about insulators and conductors. Now, you know that tape is made of plastic. Therefore, it is going to be if you said insulator, you are correct. And the aluminum foil is a type of metal, so most likely it will be if you said conductor, you're correct. So here we have our aluminum foil. You see that shiny side, and you see the tape on this side. It's not quite so shiny. And I'm just going to take it, I'm going to fold it. I put my aluminum foil piece down, and I'm folding it so that the tape is in the middle. And we are making what is called a ribbon, okay? And it is going to conduct electricity. Now, if you are right now thinking, Miss Raymond, I have aluminum foil at home, and if you're like my house, sometimes you have tape at home. Before you try to do this at home, you better check with your parent, make sure it's okay. All right, because I'm also going to use another thing that the Raymond house runs out of a lot. Batteries. This is a D battery. It has a negative end and a positive end. And then I have this cool little light bulb. Okay, so it is like this. And now you say, well, we could just complete the circuit by putting the ribbon from the negative end of the battery to the positive. And you're correct, that would complete the circuit, but it would not light up the light bulb. What it would do would drain all the electricity out of the battery. It would just be lost. That's called a short. We don't want to do that. We don't want to lose our electricity in the battery, okay? Now there are two parts on this light bulb that must be connected in order to complete the circle. This metal part around the side, as well as these two little dots of metal on the bottom. They all have to be connected. And they have to be connected to the negative end and the positive end so that the electricity can go in a circle. All right? So I'm going to put my battery on here, and I am actually going to turn out the lights so that you can see this light bulb light up. All right, I'm going to make it just a little bit darker here. Now I have my ribbon underneath the battery. I have my light bulb. I'm going to put the two little dots on the top of the battery. All right, and I'm going to put my ribbon. Remember I said that doesn't work right there because we have to connect the side of the light bulb. And there you see it lighting up. It's not very bright though, is it? Okay, there's another way I could do this. I can take the side of my light bulb and put it on the battery like this, and then I can touch the ribbon across the two little dots on the bottom. And there you see it lighting up again. All right. Now, if I put my light bulb on the side of the battery like this, okay, not on that terminal on the top, I'm not going to get it to light up because the circuit is not complete. Okay, you see it is not lighting up at all. Now you say, Miss Raymond, that was not very bright. Oh, also another thing, if I just put the ribbon on there and I put the battery on top, it does not light up then either, because remember I said this collar, this metal collar on the light bulb must be connected also to complete the circuit. And if you have said, Mrs. Raymond, that is not very bright, you are correct. We're going to do something next. We are going to create what's called a series of batteries, because I'm sure you're thinking, Miss Raymond, if you just use more batteries, because you know in your flashlights you put in 3 or 4 of these big old D batteries. Now, an important thing about batteries is if you put them positive end to positive end, like this, you see my 2 positive ends? They will create another short. It will just drain all the electricity out of the batteries and it will just disappear. Okay, it will not light up the light bulb this way. All right, what I've done to my batteries is I have taped a paper clip on so they don't roll around. And on these, I have taped my ribbon down because Miss Raymond only has 2 hands. I often think that maybe a 3rd or 4th hand would be handy, but I haven't sprouted one yet. So I only have 2 hands. Okay, I'm going to tape my paper clip down like this to the side of the battery to keep it from rolling around. So I use a lot of tape here to help this experiment go. Okay, and here I have a 3rd battery. So we are creating what is called a series. Now you may have watched a series on television. Okay, like there's the Phineas and Ferb series. I'm trying to think, I don't know what series you would have watched. There can be baseball series, basketball series, and it just means a line of games, one after the other. And that's what we have here. We have a series of batteries. They're just lined up one after the other. I did positive to negative to positive to negative to positive to negative because I don't want it to short out and not light up my light bulb. Okay, and now I'm going to take, remember I said there were 2 parts on the light bulb I had to connect. Okay, I have to connect this metal collar. So I'm actually going to just twist my ribbon around there, kind of like a twist tie. I know it's a little hard to see. I'll show you better here in a second. Okay, let me see here. All right, I'm going to make sure it's nice and tight. So you see there, I've twisted it around there, kind of like a twist tie. And then I have my ribbon from my other one. It's connected to the batteries, but it's not lighting up. So it's got my ribbon from the positive side. I'm going to put it on the bottom here. Let's see how well it lights up. Ooh, look at how much brighter that is. Okay. Well, sometimes my batteries move a little bit and they're not touching. And then that breaks the circuit and the light cannot light up. I also have to make sure I'm touching both of those little metal things on the bottom. Oh, something is making it so the circuit will not complete. See if we can get it to light up again, because you'll notice with the series of batteries, it was much brighter. Make sure the tape on the ends is holding it to the terminals. Let's see here. Something is breaking Miss Raymond's circuit. And this is not lighting up, is it? Oh, there we go. I got it. It's just the batteries. They have moved a little bit. They shift a little bit, and then they won't, oh my. Then they will not light up the light bulb. There we go. You can see how bright it is with a series of batteries. All right. And you can see also how the circuits must be connected just right. I'm having to kind of push the batteries together and hold the light bulb down on my ribbon to get it, because if that circuit is broken, and even just a little bit, it will not light up. Okay, so ladies and gentlemen, another thing I would like to test and see is, because yesterday you were testing insulators and conductors. Okay, so here I have a copper penny. I'm going to put it on my ribbon. Just going to use 2 batteries because that will light up, hopefully. Let's see if a penny is a conductor. Oh, it sure is. It lights it up. Okay, some of you are like, hey, Miss Raymond, I have this cool big eraser. Okay, so I took my eraser and put it on top. Is an eraser a conductor? Absolutely not. It didn't light it up, not even a little bit. Okay. And then I have here, oh, it's hard to see. Let me get a little light. I have a marble. Okay. Marbles sometimes are made of a plastic acrylic, sometimes they're made of glass. This one's made of glass. So we're going to see if glass is a conductor or an insulator. The light bulb is not lighting up. So glass must be an insulator also. Here I have my, my hole puncher. Let's see what this thing does. It's metal. So what do you think it'll be, an insulator or a conductor? Oh, I don't know if I can do this because, oh, it's not flat. We will try a paper clip. That's not going to work because you see the metal is curved. It's not flat. Okay. So it probably would if there was enough electricity, but there's enough electricity, I would probably electrocute myself. Let's see if this paper clip is a conductor or an insulator. You have to remember too, some metals are better conductors than other metals. My paper clip here must not be a very good conductor, even though it's made of metal, because it's not lighting it up. So some metals are better than others. In fact, one of the best metals of all is copper. Remember I used the penny and it lit up just great. Where'd my penny go? There it is. Okay, let me make sure my batteries are lined up. My light bulb. No, these ribbons get just a little bit old. They don't want to work anymore. Okay, let's see here. There we go. See, the penny lights it up just great. Okay, so let me see here. Let me try my paper clip and hold it all together a little tighter again. See if we can get this paper clip to work. I don't know though. Let's see. No, it just must not be a very good metal conductor. One of the best metal conductors that they use in wiring is copper. Copper is what pennies are made of. And you see here, it's this shiny gold looking metal. Okay, it's what pennies are made of. So this is a wire I have, and I removed the insulation around from the ends so you could see the ends. And it is copper. All right, and you'll notice they use plastic. Now glass and wood are actually very good insulators, but would it make much sense to cover this wire in glass or wood? Probably not, because it wouldn't be bendable and flexible. If it was glass and it broke, you know, you could get cuts and stuff like that. Wood doesn't bend around here. So plastic is one of the best insulators because you can make it whatever shape you want and it's bendable. And then copper is a great conductor. So let's try this. I have a battery here. Let's try this with a copper wire and see what happens. Ooh, you know what? It's a little bit warm. The light bulb gets a little bit warm because we have some thermal energy being released by the electricity as well. And I know I told my class a lot of times those different forms of electricity are closely related. Okay, so let's see here. What's the best way to do this? I'm going to do a series of 2 batteries. Let's see if Miss Raymond can get this to work. I might not. I'm going to put it this way and this way. Okay. Oh, see, Mrs. Raymond needs another hand again. This is not easy. Okay, and hopefully it doesn't get too hot. There you see it lit the light bulb up. And the copper lit it up better than those ribbons, didn't it? Because I have the lights on and you can still see how well that is lit up. So what this tells me is copper is an even better conductor. Ladies and gentlemen, that is all we have time